All right, so today's notes are on solving polynomial functions. Our content objective is to solve polynomial functions by factoring, and our language objective is to use the correct terminology to explain that process. So our first example asks, what are the real or imaginary solutions of the following polynomial? And we have 3x to the fourth plus 12x squared equals 6x cubed. So we're going to just jump right in with this. So again, if we're going to solve by factoring, hopefully you remember from quadratics, our first step is to always set the equation equal to 0. So to do that, I need to subtract 6x cubed from both sides. And I'm going to put that in the middle here because I want to write my polynomial in standard form. So I set equal to 0 by subtracting 6x cubed from both sides. Then I'm going to factor out a GCF. So I notice here that all three terms are divisible by 3, and all three terms have at least x squared. So I'm going to divide out 3x squared. So I have 3x squared equals, times x squared minus 2x plus 4 equals 0. So now I have successfully factored out a GCF. I cannot factor any further at this point. So I can, but luckily these two terms, I have 3x squared times x squared minus 2x plus 4. So since these two terms are being, or these two expressions are being multiplied and equal to 0, I can still use the zero product property and set each one separately equal to 0. So now I can say 3x squared equals 0 and x squared minus 2x plus 4 equals 0. So even though this isn't factorable, I can continue my solving process by using the zero product property because I was able to factor out at least part and make two expressions. So I'm going to start by solving each one. Solve both equations. So the first equation is a little bit easier. I'm going to divide by 3, get x squared equals 0, square root both sides. X still is equal to 0. So x equals 0 is one of my solutions. I'm going to keep solving this one. So at this point, you could use the, you could use completing the square or the quadratic formula. So whichever you're more comfortable with, you could use at this point. I'm going to use the quadratic formula, but either one is completely fine. So, all right, use quadratic formula or completing the square. So actually, I'll complete the square. That'll be easier. So I'm going to subtract my 4 from both sides. I get x squared minus 2x equals negative 4. I do negative 2 over 2 is negative 1. So I have x minus 1 squared equals, that's x minus 1 squared equals, and then I'm going to add 1 to both sides. So equals negative 3. So then I'm going to continue by square rooting both sides. I get x minus 1 equals plus or minus I root 3. So in case you're curious how I got I root 3, I had a negative number under a square root, so I know it's going to be an imaginary solution. So I take out the negative sign by putting an I in front of my radical. Again, since I took a square root, I have to put plus or minus. So my last step is to add 1 to both sides, and I get x equals 1. That's a plus 1. Plus or minus I root 3, and that is my other two, or those are my other two solutions for this quartic polynomial. So I have 0 x or 1 plus I root 3 and 1 minus I root 3. Again, 0 would have a multiplicity of 2 in case you forgot that from last time. So we have multiplicity 2 in case you've forgotten that. So those account for all 4 of my solutions for that quartic polynomial. All right, so we can do, actually I'll skip the quick check for now. So we'll do some practice with this in class, but again, you are factoring, using zero product property, and then you can continue solving your quadratic with whatever methods you know how. But just a quick refresher, actually I can fit this here. from our methods of factoring. So polynomial factoring techniques. And I'm going to show us one new one in addition to the ones we know. So we know how to factor out a GCF. We just did that in our last example. We know the middle term splitting method. And again, these are, like I mentioned earlier this year, it's always really important to know factoring. It will keep coming up. So we know the difference of squares. We know factor by grouping. So this is just the middle step of middle term splitting method. If you forgot what this looks like, I'll do a quick little demo. So we have ax plus ay plus bx plus by. We group the first two and the last two. Take out the a, we have x plus y. Take out the b, we have x plus y. And we end up with a plus b, x plus y. So if you've forgotten middle terms, or sorry, factoring by grouping, that's what that looks like. So those are the ones we've already done in our quadratics unit, but I want to show you a couple of new ones that we need to know at this point. So I'm going to flip the page for these. So the new ones are the sum and difference of cubes. So we know the difference of squares, so a plus b, a minus b equals a squared minus b squared, or a minus b squared equals a plus b, a minus b. But the difference of cubes, or sum of cubes, we'll start there. So we have a cubed plus b cubed. And that ends up factoring to a plus b times a squared minus ab plus b squared. So an example, because I know that all those variables might look confusing, is if we had 8x cubed plus 1, the cube root of 8x cubed would be 2x. The cube root of 1 is 1. So when I factor this, I'm going to have 2x plus 1 times 4x squared minus 2x plus 1. So again, I've just followed this pattern. The 2x squared becomes 4x squared because I squared the whole thing. So I'll do the in-between step. So 2x plus 1 times 2x squared minus 2x times 1 plus 1 squared, which simplifies to that. And this is the shortcut we can know for the sum of cubes. The difference of cubes is actually pretty much the exact same thing. The only thing that is different is the middle sign here changes and the middle signs here and here change. So a cubed minus b cubed is equal to a minus b times a squared plus ab plus b squared. So again, the only thing that changes is the first two signs when you talk about the sum or difference of cubes. So factoring this, we'll do a different set of numbers. For example, actually we'll do the same numbers to make it easy. 8x cubed minus 1 would factor to, again, the same 2x minus 1 times 4x squared plus 2x plus 1. So again, same thing. The only thing that changes are these two signs between the two examples. All right, the last thing I want to show us today is another factoring technique, which is factoring, so let's start here, factoring quartic expressions like quadratics. So sometimes we'll end up with quartic functions that can be factored as though they are quadratic. So we're going to do an example of that real quick. I want us to solve x to the fourth minus 3x squared minus 4 equals 0. So again, make sure it's always set equal to 0 to start. I did that for us in this step, but it will not always be equal to 0. So what we're going to do first, step 1, is rewrite x to the fourth as x squared squared. So I'm going to take the same expression, but instead of writing x to the fourth, I'm going to write x squared squared. So if you recall, power to a power, you multiply those. So x squared squared is the same as x to the fourth. Then I have minus 3x squared minus 4 equals 0. Now I'm going to substitute a for x squared. So I'm going to substitute wherever there's an x squared, I'm going to rewrite it as a. So I end up with a squared minus 3a minus 4 equals 0. At this point, this is just a normal quadratic trinomial. I can factor per usual. I've done this hopefully a bunch of times before, or I have, hopefully you have as well. So I'm finding factors of -4 that add to -3. I get a minus 4 times a plus 1 equals 0. Now I'm going to substitute x squared back in. So now I'm going to substitute back in. I end up with x squared minus 4 times x squared plus 1 equals 0. And now I can use the zero product property. I actually, just to refresh your memory, since we're talking about factoring methods, I'm going to factor the difference of squares. Hopefully you noticed that. If not, that's okay. But I have two perfect squares being subtracted, so I can rewrite this as x plus 2, x minus 2 times x squared plus 1 equals 0. I use the zero product property. And I can say x plus 2 equals 0, x minus 2 equals 0, x squared plus 1 equals 0. And I'm going to solve each equation. So my last step, I get x equals -2, x equals 2, x squared equals -1. I square root both sides. Square root of -1, x is going to be plus or minus I. So my last two solutions to my quartic are going to be plus or minus I, because the square root of -1 is indeed I. So that's all for today. Make sure you write down any questions, comments, or concerns you have on this stuff. I know it's a lot, but we'll have time to practice it in class.